Hello, everyone. My name is Kintautas. I'm a DevOps engineer at Zenit Tech. I've been working as a DevOps for more than 1 year and been working with different technologies for system automation. Today, my topic is related to one of the most popular frameworks for DevOps system automation, Ansible. It is used by many companies nowadays as it simplifies scripting for system administration. Today's topic is not how to use the framework for administrating systems, but about Ansible projects. We will learn how to simplify project creation and maintenance. For managing projects, we will use our own concept, skeleton, which is the core aspect of today's presentation. First of all, I want to introduce Ansible. It's an open source software that simplifies system provisioning, configuration management, and application deployment. That means you can use the framework to write YAML language-based modules to install software and other dependencies on virtual machines. Also, with Ansible, you can manage files, permissions, and configuration of your systems and deploy your applications to virtual environments. So this framework provides a simple language that replaces scripting for system automation. Ansible script is divided into several main components that are inventories, a list of hosts to which we will connect, roles, small reusable code pieces, playbooks, main Ansible program files, and variable files where we keep our variables. These components make Ansible code more structured and code more reusable. I will talk about these components in the next slides. First of all, I want to introduce Ansible inventory. It is one or more files where we define hosts and groups of hosts on which we execute our scripts. It is a file where we keep addresses of our machines along with authentication keys. On machines which point to these addresses, Ansible scripts operate and execute automation tasks. It can be a simple IP address of a machine to which we want to connect and provision, or it can be many different addresses divided into groups. Here's an example inventory file. It defines one host to which we connect. It's 192.168.0.91. So we'll connect to this host and execute automation scripts here. We provide authentication method, which is SSH, and we provide path to SSH private key file. So now when we have connected to the host, we want to run scripts on it. So let's talk about Ansible roles. So Ansible script can be divided into more simple parts, which we call roles. Role is a file or group of files which runs a specific task. It can have its own structure, like defaults, vars, tasks, files, templates, meta handlers, and we can reuse our defined roles in our playbooks. So role is a smaller reusable code which does a specific task. Here's an example Ansible role. It provisions MySQL database on the host. So it installs MySQL DB. We use an Ansible built-in task MySQL DB to install MySQL database on the machine. We define our variables here, and the script automatically provisions a database on the machine. We can use this task in our playbooks and reuse it as much as we want. Now let's talk about Ansible playbooks. We can group our roles into playbooks. A playbook is the main Ansible file where the main code is written. Playbook is one of the core features of Ansible and will tell it what to execute. They're like to-do list for Ansible that contains a list of tasks. So let's check an example playbook. This playbook connects to the host with the name myVM and provisions the system. We define var file, which we will use for variables, and roles, which we will use and execute on our host. So we define two roles, and two roles will get executed on the remote machine that are system update and enable static IP. So it's the main code and it runs script on the machines. As I mentioned in the beginning, Ansible Skeleton is our today's main topic. Ansible Skeleton is our company's internal solution for Ansible project automation. The skeleton is a collection of roles and playbooks stored in Git, along with the scripts that automate role or playbook creation and make them easily reusable. In the skeleton, we have scripts for creating role, playbook, and script for synchronizing to skeleton in Git. When starting out, we fetch our skeleton from Git. Then we add new roles and playbooks using Python scripts. Once a role or playbook is ready for production, we use a script to push them to skeleton in Git. Therefore, our library of roles and playbooks grows. Why do we need skeleton? Well, it makes it easier for us to create an Ansible project and manage our roles and playbooks. It means we have predefined Ansible project and a set of ready-to-use roles and playbooks for the project. We also add new roles and playbooks to project skeleton and synchronize our local project with the newest set of roles and playbooks in a remote repository. So I will tell a little bit about this diagram. So skeleton is stored in Git. In the skeleton, we keep a library of roles and playbooks along with automation scripts. And we can add the new roles and playbooks to skeleton and execute automation scripts on our machines. So why do we need skeleton? Problem is that we want to reuse our Ansible roles and playbooks in our projects. To solve that, we have predefined roles and playbooks that we use throughout our projects. Those predefined roles and playbooks are stored in remote Git repository where our skeleton lies. When we have skeleton, we can keep our roles and playbooks up to date, synchronizing them with skeleton stored in Git. We pull our roles and playbooks from Git and push new ones. How do we automate? We use Python to write a simple command line interface and scripts for Ansible project skeleton automation. To use our skeleton, you will need to have Python installed along with required dependencies. Once we have Python and its dependencies installed, we run Python script from command line. Then we are provided with a menu of tasks we want to accomplish. When we select a menu item from a list, our Python scripts get executed and they do work for us. How does the skeleton work? So here we have used Python scripts that help us to synchronize our project with the remote. We put our roles and playbooks into Git, from where programmers can take code. When we create new project, we fetch roles and playbooks from Git with the script included in Skeleton. When we create new ones, we push them to Git with another script. What do we automate? Well, we have a script that creates a new Ansible project folder with the required file structure. Also, we automate playbook creation. We have a script that creates Ansible playbook with the required files and folders. We automate role creation. We have a script that creates an Ansible role with the required files and folders. We have a script for pushing roles and playbooks to Skeleton in Git and synchronizing with Skeleton. Now it's time for a live demo. So here is Ansible Skeleton fetched from here, Git. It has its own structure. It's a folder where our playbooks go. We put all our playbooks here. We put all our roles here in roles folder. Here's one role that I pushed to Skeleton shell command role. There's also a folder for scripts, the main script for creating a project, a script for our inner templates. It's for project creation and for scripts for creating playbook, creating role, pushing the skeleton, synchronizing with skeleton. And the main script which we will need to run is run.py. Of course, you need the required dependencies installed, and you can then begin working with your project. So I will run the main script. I'll execute Python script from command line. And here's a menu item, create project. We'll use it for creating project, and it will appear here in our projects directory. We click create project, we enter project name, for example, test project. We can enter our full name. Enter our email. And here the project was created. It goes to projects directory. The project doesn't get pushed to Git. We use git ignore, so the projects directory is ignored, but we can synchronize our roles and playbooks with remote. So here is project directory. It has its own structure with inventories directory, playbooks directory, roles directory. It's the same structure as this. And now we can start working on our roles and playbooks and implementing our project. Now, what I want to show you is when synchronization with the skeleton. So we open our projects directory. And here's an example. If someone is working on another role zone or playbooks, we can synchronize it with our skeleton. For example, so there is no role shell command. We can delete it. There is no role, but it's in skeleton. And now we need to synchronize our project with the skeleton. So we run.py in our projects directory. We then select synchronize with skeleton, and our roles and playbooks will be synchronized with remote. There's an RSA key. And now the roles and playbooks folders appear the same as they are in skeleton. In skeleton, there are no playbooks currently, but you can add them. And there's one role shell command, which was downloaded from the remote Git repository. I can show you it is in our Automate IT Ansible Skeleton. After the presentation, you will be able to download our skeleton, and in roles directory, there's one role shell command. So we have synchronized our roles and playbooks with the remote. Now we want to add more roles and more playbooks. So we execute the main script, which is in our project directory. We click create role, enter our full name. It will appear in the roles README file. We enter role names of roles we want to create. For example, role 1, role 2. We can enter one or more roles, and they will be generated automatically. We click enter. We insert role location. The default is projects directory roles. We click enter to select the default location. And now 2 roles have been created for our project. They have the default structure with folders, files, handlers, tasks, templates, variables. And now you can implement your role by editing those files and folders. Now the README file has been generated automatically. It looks like this. You can define variables that you use. You can have files that you use. Here's an example of how to call role 1 from Playbook. And also your name and surname was inserted, and an email was inserted into README file. So, okay, we created 2 roles. Now we can create one playbook, for example. Create playbook. We, for example, create test playbook. In the default location, playbooks directory. And here, our test playbook has been created. It has the default structure, main YAML, and files folder. It has a README file which was generated for us. And we can edit the README file from our playbook. And that's all. We created one playbook and 2 roles. Now, once we are ready, we can push our roles and playbooks to our remote skeleton so everyone can use it for their projects. So we run the main run py in our project directory. We select push to skeleton. Now, for example, we want to push this playbook to skeleton because we have developed it fully and everyone can use it. For example, we want to push role to skeleton and everyone can use. So click enter, and now we push our roles and playbooks to remote. So Kintautas playbook and role 2 was pushed to remote. So now everyone will be able to use it after we create our pull requests. when we match our pull request to the roles and playbooks directory, those roles and playbooks will appear here, and you can synchronize in any other projects. So the test playbook and test and role 2 was pushed to remote. So you can, before using our skeleton, you will need to go through a README file which is in the main directory. I added automate IT information also for us. So to use our skeleton, you will need to change some scripts like push to skeleton and single skeleton, run py files. You will need to set correct git skeleton URL, it's SSH URL, and correct master branch name. In those two files, then you will be able to push and sync with your own skeleton in your remote location. So here's the README file, don't forget to read it. There's also requirements text for required dependencies. And that's all. Now questions.
Thank you, Kintautas, for a great presentation. So we have one question, anonymous question. Anonymous attendee asks, says, hi, in the beginning, you mentioned that you are quite new as DevOps, and I wonder why this field. I'm totally new in IT and I can't decide between Dev and DevOps.
Well, I'm not so new in IT. I have experience in JavaScript development, both front end and back end. I enjoyed the developing in front end, but I wanted to try something new. So I joined DevOps as junior engineer.
Okay, thanks.
It's an interesting thing to do. So you can try also, but you can choose any other field that suits for you.
Thanks, Kintautas. And another question from Evelina. Have you tried other tools similar to Ansible? What are the advantages of Ansible compared to other tools?
Well, I have tried Terraform. We use Terraform daily in our job process. So the Terraform is used mainly for infrastructure, and you can use Ansible also for infrastructure. But Ansible is suited also for system configuration and other infrastructure things, like also configuration management. So with Ansible, you can do more. There's also other tools like Chef or Puppet. They are maybe similar. I haven't tried them, but I think they're similar. So you can choose software that is the best for your job, that your company uses, or you can choose whatever suits you.
Okay, thanks. And one more anonymous question. So is this solution that you just presented is usually used by DevOps engineers at the company that you're working, or it can be used by someone else as well, and not depending on the role or the position?
Anyone can use it who develops projects with Ansible. It simplifies project creation, maintenance, maintaining those library of roles and playbooks. When everyone works on different projects or the same project, and those who work with Ansible can use it. So any job.
Thank you, Kintautas.